Hi guys, today I just want to go through some strategies of how to solve complicated equation. And just one thing to keep in mind, so every time you ask to solve something and you got more than one solution, so make sure you go back and check to see if all solutions are applicable. So it could be, the initial conditions or what they give you in the question. So in this question, you asked to solve an equation. So the left hand side is a linear. That's easy enough to sketch. So that's a blue line. On the right hand side, so what you can do is you sketch the modulus of x minus 4 first. So it's just like that. And after you've got the modulus of x minus 4, you can sketch the reciprocal of it. And as you can see from here, the vertical asymptote should be x equal to 4. And then you look at the two branches here. For the left branch, it will give you this curve, the reciprocal of it. Because as y is approaching 0, so 1 over 0 should be approaching infinity. And also when y is approaching infinity, 1 over that should be approaching 0. So that's how you got this shape here. And the same principle apply for the right hand side. So when you have sketched the graph, you can see that the blue line and the red curve only intersect, over here. So you don't even need to worry about these parts. Now you need to work out what the equation of the red curve is without the absolute. And hopefully you can work that out easily. So the green line is equal to basically negative x plus 4. So this one is just a reciprocal of it. So that's how I got 1 over 4 minus x over here. So you want to solve that. So rearrange to form a quadratic equation and then use the quadratic formula to work out your x value. Now you can see that you got two x values, but only one of them is applicable. So you choose basically the smaller value in this case. So this question is about the range. So you're given k times tan inverse of a x minus b plus c. So these are all constants. So you need to work out for what value of c, f is always positive. So in this case here, you have to use the horizontal asymptote. So we know that the horizontal asymptote of tan inverse are negative pi over 2 and pi over 2. So you can apply transformation like this. So you times tan inverse by k and then you add the c. So basically you have a dilation from the x-axis and then you got a vertical translation as well. So if that's the case, then your horizontal asymptote will become so negative k times pi over 2. This one is a lower asymptote, okay? So you times pi over 2 by negative k, and then you add c to it. Because you want the function to be greater than 0, that means you want this lower asymptote to be either 0 or greater than 0. And then from there you can solve for c. So c depends on k.